Hi, my name is Dr. Iterative. Welcome to the second session of Elements of Software Construction. Here is our outline. Right? We will start by introducing software development process, or SDP, have a glimpse of what the entire development process is all about. Okay. Then we'll move on to the 4 elements of software development. They all begin with P's. That's why we call them 4P's. Then we will get to know some specific development methods or models, including a few sequential models and some iterative and incremental models. And in the next session, we will discuss agile development methods. This is going to be quite a long session, around 50 slides long. So normally we split them into 2 lectures, but since it is a YouTube video, I will just record them together and let you decide to watch, pause, or even ignore whenever you like. In any case, all sections will be bookmarked so you can jump to any section however you like. Without further ado, let's begin. Last time we mentioned that software is a solution to a problem. All these screens you see solve problem, either business, social, or sometimes if you got dumped by your girlfriend or boyfriend, other game time would help too. Anyway, if a software is a solution, the process of building solution is the process of problem solving, not just coding. First, you need to understand the problems, which can be translated to understand your users. What do they want? Why do they want what they want? The why is the most important thing. More often than not, once you understand the why, you might figure out what they want is not what they want. Or could there be a better thing that they should want? They just didn't know about that yet. I know you're confusing, so let me explain. When the users discuss their problems or requirements with you, they usually have some solutions in mind. For example, a convenience store owner might want something like 7-Eleven, where the cashiers have barcode scanners that can scan the product barcodes. But what if you could use RFID or some other AI or some other methods instead? Something that the customer can pick up products and pay by themselves, for instance. Or better yet, the system recognizes the products and makes payment automatically. The customer just walks in, pick up what they want, and then leave. Everything goes automatically in the background. Well, Lotus has some of those stores already. So you can offer them better solutions if you realize that what they want is just a sales point management system, normally called point of sale or POS system. It doesn't have to be an ancient thing like the machine or computer with barcode scanner, but anything that allows the customer to pay and pay fast. Remember, you are the engineer here, the software engineer. You know your techie stuff more than them. And you can offer better solution. Not all the time, but most of the time. Right? And this is one of the key topics that we will discuss in this course. Next, we propose a solution. That is a plan or model of the software to solve your user's problem. The solution or the software that you're going to build must, of course, follow a good plan and a good design. So what is a good design? It is a design which yields the solution that solves the problems, of course, but it has to be easy to implement, easy to extend, and more importantly, easy to maintain. Speaking from my own experience, maintaining the software is usually harder than just to build one. You could always build a software that is quick and easy, solve the problems today, I mean the present problem, but it is very difficult to change things, very difficult to extend, very difficult to add new features. All right. Creating a good solution or good models is also about dealing with complexity. When you go meet your customers or you go meet your users, they're gonna tell you what they want. They're gonna tell you about the problem that they have, what they do each day, what kind of documents that they have, and so on. And this could get overwhelmed quite easily. All right, what kind of data they're gonna keep? What are the form or the fields in each questionnaire or in each kind of list or each kind of product they keep? All right, it could be and also the process that they do. Okay, for example, in 7-Eleven, all right, or in convenience store, there are a lot of process, a lot of work to be done. All right, each day, for example, when the customer walked in and they pick the product, okay, they go pay and pay in the cashier. The guy at the cashier taking the product, scan barcode, make payment, collect your payment. All right, and the payment could be of many choices: cash, bank transfer, credit card, True Wallet. You know all this. All right, and these payment methods. All right, each of these payment methods, you need to handle all of them. And after that, okay, the customer walks out, but the job of the staff at 7-Eleven is not done yet. All right. At the end of the day or at the end of each shift, they might need to check the stock. Okay, if there anything missing, is the stock is the shelf are being empty? Okay, something has to be filled, something has to be replaced. All right. Each of these tasks, there should be specific workflow for that. The customer, or no, the user or the staff in the store, all right, they have to do specific steps to complete task. All right, and when you go interview, talk to your customer or the user, they're gonna be like, okay, we need to do that, you need to do that. And in one 7-Eleven, there could be like 20, 30, 50 things to do, and that could get overwhelmed quickly. And people, all right, when they go talk to them, they always tell you details. Like, okay, we need to adjust this, the counter or the shelf like this, and this has the green one has to go there, the red one has to go there, and so on. And then and a lot of these details, all right, you need to consider which one should I keep, which one should I care, which one should I ignore or discard. All right. And once you see the big picture, once you listen to the customer, think about all the flows, you're going to start to create a model. All right, the workflow. Sometimes a lot of workflows, a lot of activities, a lot of steps could be combined into one. Sometimes it has to be expand into many flows, all right, or many subflows. We're going to talk a little bit more on that also. All right. So anyway, creating abstractions and models is a way to deal with complexity. You are leaving the complicated stuff, the unwanted stuff away. You leave it behind. You are going to ignore them. Yet, at the process of ignoring, you need to always keep it in the back of your head that my program, my software has to be able to be extended. All right. That means that sometimes you need to keep things that you don't want to do it right now, you don't want it right now, but you keep it, or you have some place left in your data structure, or database schema, all right, or somewhere in the control, so that it can be extended easier. As I was saying, maintaining a software is a difficult task. Usually it is more difficult than just to deploy 1 or 2 versions, right? Because you don't know what the customer want, what the customers will want in the future. You need to be able to expand and handle all these new emergent requirements. Next, notation for abstractions. And of course, one of the most difficult tasks to do in software engineering, all right, is naming. Give things name. Your class name, your object name, your process name, all right? Maybe the user role names, for example, cashier staff, store manager, all right? Stuff like this has to be defined. And once the project got larger, got more complicated, naming things could also get complicated as well. Like I call this user staff. What should I call the other guy? What should I call the guy that delivered the product? What should I call the guy that store the product at the end of the store? Or counting stock, all right? Are they the same guy? Should there be different user roles? How should I call them? Something like this, all right? Software construction is also about knowledge management. The process of collecting requirements from users, what they want, why do they want that, what are the workflows, what are the goals, what are the tasks. These things are the process of requirement elicitation, okay? But next, after you gather all these requirements, you need to analyze them to understand what the user really wants, what should be the solution, okay? And then you design the solution. And the process of designing, analyzing, requirements, collecting requires some place to store. All right, and the result of these steps require a place to keep. And that is knowledge management. How can you keep all the things that you have just collected and created, designed? Right? There are languages for that. We had a introduction to UML quickly last session. All right, we're gonna dig deeper into the subsequent sessions as well. How can we deal with all the things that we have just learned or created? All right, and after that, when the system is designed, okay, you might want to validate the design, whether it solves the solution or not. When the system is implemented, okay, you need to also test the system, whether it solves the problems or not. Okay. Lastly, it is rationale management. You want to make the design and development decisions explicit or known, understood by all stakeholders involved in the project. Now let us discuss software development process as a whole. Okay, you've seen this picture before. This is what we call software development process or software development lifecycle. All right, we start from planning. Have a look real quick. What should we do? All right, whether it's feasible, whether it makes sense to do. Okay, can we make money? Can we make a business out of it? All right, and after you pass your feasibility test, you move on to the requirement analysis. And then after that, okay, you move on to designing the solution, okay, and then moving on to implementing the solution that you designed. And after implementation, you move on to testing and deploying your product to the customer. And the customer used it. All right. After the customer uses it, after the product is deployed, you are going into the maintenance mode. All right. Keep it running. Keep fixing things, keep adding things, all right? And in this process, you can also collect more requirements and start building new version, adding new features, and this cycle goes on and on and on, all right? So, and this is the idea. Now let us have a look at the more detailed version. Here, we split the design step into two phases, the system design and the detailed design. All right. Now, and you're going to see this green line here that split what we call the application domain and the solution domain. Have a look at these 3 points. In the planning phase, you design what is your problem, and this what what you concern here is the big picture. Are we designing system convenience store, or are we designing system for car manufacturing plant? Okay, are we designing software that runs in a rocket ship? Okay, what is actually the problem in the big picture? You move on into after you figure this out, all right, and you know that okay, it's feasible, it's good for business, it can make money. You move on to the next step, the requirement analysis or requirement elicitation. And in this elicitation process, you explore deeper. What will be your points? I mean, what are the important features of your software? All right. What would be your users? How many kinds of user do we have? All right. And after you have a list of requirements, all right, for each of the users, you are starting to thinking about the solutions that solve these users' problems. And in this step, okay, you might come up with the set of components of your system. Okay, we have to have the input, we have to have the server, we have to have the database server, all right, and we have, if you're gonna do this, make a system for convenience store like 7-Eleven, you might think of the POS machine, all right, the machine at the cashier, maybe the server at the end of the at the back of your store, or maybe the other one to do the stock checking, to take in some products, to return some product, stuff like this, right? And might also think about what are products, what are shelf, what would be your payment types, something like this. These three steps belong to what we call the application domain. But what is the application domain? All right. The application domain refers to the problem itself. This is where you are trying to describe the problem, right? Well, to be more specific, the term application domain refers to a specific area or a field in which the software application operates or it is designed to address. It represents the subject matter or the problem space that the software system is intended to solve or to support. This includes the context, the requirements, or constraints, set of users, or any other thing, all right, that could influence your design or the development of a software. The next phase is the detailed design phase. In this phase, it is where you further refine or transform your requirements, all right, your system design into more detailed and comprehensive design for the software system. During the detailed design phase, you work on translating the requirements and the system design or architectural design into a lower level design that specifies how the system should be implemented. The primary goal is to provide a plan, a model, or a blueprint, okay, and also the roadmap for the construction or the implementation of the software. In this step, okay, the key activities that one could do includes component design. Okay, you decompose the systems, you decompose each component into smaller subsystem or subcomponents. Okay, you can also do the data design, where the data structures, the database schemas are being drawn or are being drafted or are being defined. All right, you can do the UI design as well. All right, and in detail level, UI design can be also done here and here, but the more detailed version, the precise version of how the app should look like, can be done here as well. You can also design your algorithm or define, can pick any algorithm. Okay, if you don't have to, draw out one yourself, I draw one yourself. You might want to select the algorithm that best solves your problems. Okay, and any other activities that you need to prepare before you actually implement your software. And after you have the detailed design in hand, you can start moving on to the implementation phase. Okay, right here you think about how the solution is constructed. How can I code this? How can I write this piece of solution, a piece of software? I don't have to explain much about this. Then you move on to the next step. After you implement your code, okay, your software, it could be the entire software, it could be a subcomponent, it could be a component, or it could be a function. Whatever, however you want to do it, after you code, you need to test. Again, it could be just one class or one function that you could test by yourself. All right, maybe one component, maybe one UI page. Okay, then you can also test yourself, or you can just ask your friends or your PO to have a look. How does it look like? How does it behave? All right. After that, okay, you move on to the bigger level. How different components should fit together. Did they fit correctly? The output of component A is the input of component B, and you need to also check whether A and B collaborates correctly. Okay, and that is a step, the phase we call the integration testing. And then you're moving on to the bigger picture, or you test the entire software, whether the whole thing works correctly or not. Okay, this step usually involves the user. We call this the system testing. And before you can submit, all right, your project to the customer to cash out, you can do the user acceptance testing, kind of final testing, where you allow the users to really go through your system and see if thing works as it should work, right? And then after you test, you could you deploy your system somewhere. All right, it could be on a phone of the user, it could be on a PC, on a Mac, or it could be on a server. It could also be a web app. All right, and it had to be deployed on a server, and then you let the user connect to your web app through web browsers. And after your project is deployed, you switch to maintenance mode. All right, you think about how can I enhance my system. Okay, is there any new features, any improvement? Okay, any bugs to be fixed? And it goes on and on and on. So let's have a look at each phase in detail. All right, the first one, the planning phase. This is the shortest phase, yet I find that it is the most important one. All right, it is the initial short step to establish the common vision or basic scope of the project. So basically, you need to decide what are you going to do. Sometimes this step is called the inception phase. All right, this is just the very basic version, basic idea. All right, in this phase, we try to answer these questions. What is the vision and business case for the project? Whether it's feasible, should we buy it or should we build one? And we can also do some rough estimation. Okay, how much did it cost? Okay, I'm going to come back to this real quick. And should we proceed or should we stop? Let's just have a look at the first one first. What is the vision and business case for the project? So basically, you need to decide, okay, what should I do? Sometimes this software that you are building comes from the problems. For example, we want to manage the store. We want to organize the car queue. We want to keep track of the student GPA. We have problems, and therefore we need a solution for it. But sometimes there is no specific problem. You just feel you have some pain points, you have something that you think that, hey, I can do this or I can fix this. That could be a better game, that could be a better social media platform, something like this. But can I sell this? Would it make sense business wise? Can I just make it for fun? Can I just do it for fun? All right, that could work too. All right, but most of the time when you decide to do something like this, you must invest on that. All right. The first thing is, if you're a good developer, if you can do it, you can invest your time. All right. But most of the projects, you don't invest just time. You also invest some money to hire other guys. All right, to do some parts or do the job for you. In any case, you just have to invest. Right. Now you think about that. Okay, I have to throw in, I don't know, 10,000 baht, 100,000 baht. Would it feasible? Would it make sense if I invest my time on this, or if I spend my money on this? Would it returns? Okay, would it make money in the short run, mid run, and long run? Right. The next thing is, most of the problems, especially in business world, there are some solutions already available. So basically, we can just buy it. All right, I am sure. Okay, I know for a fact that if I want to run convenience store like 7-Eleven, I can just buy one. There are a lot of them. All right, but are these solutions solve my problem? Okay. Well, sometimes your solution is just new. Like when Facebook got invented, nobody knew about this thing before. Nobody had this idea before. So when this Mark Zuckerberg, or I don't know whoever it is, whoever it was really, had this idea, there were no solution. All right, they just have to build one from scratch. But to manage hospitals, to manage convenience store, you don't have to. But sometimes the solutions that are available, all right, either too expensive, too complex, or it just simply doesn't solve your problem. You have some requirements specific, so special that none of these solutions can solve. Then you can build one. All right. Sometimes there are solutions available. Sometimes, and then you just have to think, okay, should I buy it or should I build one? The most important, the questions about buying is not the price you would pay today. All right, it is also the price that you might need to pay later. For example, software like ERP system or database management system like Oracle, they don't just charge you for the software. They also they charge you for the software, but it is not like buying Microsoft Windows where you can just pay $100 or I don't know 1,000, 500 baht or something and install on your machine and can use indefinitely. Most of these corporate software, they calculate the price based on number of users. So how you need to pay for that is they're gonna count like this. How many users that would use my software? 10 people, 20 people, and then you need to pay for these 20 people per month. So it's gonna be per person per month. And sometimes you pay cheap upfront, but you need to pay a lot in the long run. That for some people wouldn't make sense, and they choose to build the solution by themselves. But this is the key point here, and it is a very important question. All right. Sometimes, even though you need to pay you need to pay per person per month, it's still cheaper to buy it because you don't have to build and maintain the software later. You pay somebody to maintain for you. All right. So next one, either you're gonna buy, you're gonna build. In order to know whether this idea is feasible or not, you need to get the price. You need to know your budget or cost. You need to be able to estimate your cost. And that, all right, you should do it right here in the planning phase as well. But, well, because you haven't collected the requirements just yet, you haven't really explored all the angles, all the workflows, all the components, you haven't done that. You couldn't get the precise costs. Okay, you couldn't estimate in detail, but you might be able to get the range. Okay, which ballpark are we talking about? See, it works like this. When somebody contact me, all right, they have problems, and then they ask me for solutions, I usually go like this. Okay, this is your rough idea. Okay, this is your rough requirements. Okay, maybe like 10-20 points, and have a look at that, or listen to in a meeting on phone. Experienced developer usually they usually can estimate something like, well, I think compared to the other projects that I have done, and they are about the same size, and I have done that for about 2 million baht. So I would say 2 million, yeah, plus minus. Or maybe it's 500K, maybe it's 1K, right? But usually people can do that. And if it is like way over budget, then maybe it's not feasible. Maybe it's not for you. Or maybe you need to invest more. You need to find other investors. Okay. But if the price is like, oh, this is million? 1 million baht. Well, I think I can make 5 million out of that. So yeah, it's a good business. So maybe you want to do it. And right here, once you know what you want, even though roughly, you know, okay, how much does it cost roughly? You know, all you have some idea whether you're going to buy it or going to build one, and you think about feasibility, and then you decide, should we proceed further or should we stop? Right here in this planning phase, normally people takes around a week or 2 weeks, or maybe just a month. All right. If you find something better to do, it is not feasible, then just go on, do something else. All right. Shouldn't invest too much on this. Now, if you decided that this project is feasible, we will go on. You move on to the next step, the requirement analysis or the requirement elicitation phase. Here, you try to obtain detailed information of your product or the project. Okay. Specifically, you want to know what the users or what the customers, what do they want? Okay. And what do they need? Why do they need them? You try to figure it out, okay, what kind of problems that this software is supposed to solve. Specific products, features, and functionalities and performance, reliability, usability are to be determined. So to summarize, you need to know what the software is supposed to do. And also, what are the constraints you need to follow? The speed, the platform, you need to follow some rules, you need to follow some regulations. All right. The next step is the system design. You are starting to determine how the software should be constructed. Okay. It is categorized into 2 levels, the architectural design and the detailed design. Okay. In the architectural design, you focus on the overall high level design. What are the components? What are the subsystems? Okay. How they are connected together, how they are related to each other. And then in the detailed design, okay, for each component and for each subsystem, you move further. You try to specify how each of the subsystem works. And not just that, how they communicate to each other. What would be the output of subsystem A, and what would be the input of subsystem B, okay? what kind of output and input. For example, the output should be string, the input should be integer, the input should be an array, okay, and it outputs some true or false answer, something like this. You also talk about the algorithms. What kind of algorithm should I use? Okay, do I need to derive one? All right. Data structure, database schema, user interfaces, system interfaces, and so on. After you have all the designs and plans and all requirements in hand, the next step is coding. All right. This is the phase where you translate your design into a programming language and later on compile or deploy into the software that the users can use. We can roughly define the coding step. Okay, we can divide them into two sub-steps. Okay, the first one is the subsystem implementation. The other one is subsystem integration. In subsystem implementation, you pretty much code each function, each library, okay, each subsystem, each component separately. And then once you code, you test whether the subsystem has run correctly individually. And you have another one. Okay, it works now. You need to make sure that the two subsystem works together properly. Maybe this produce some results, and those results are used as inputs of the subsystem, and then the subsystem produce some other result, and of course this subsystem take in something as the input. Okay, you want to make sure that everything here from this input to this output is correct, and that is subsystem integration. And of course, you need to code both the internal workings and the interaction between subsystems. The results of this phase is obviously the source code and the object code or the compiled code that is ready to be tested and later on deployed. After you finish implementing, either it is a small function, small subsystem, small component, larger subsystem, combination of many subsystems, all right? You need to make sure that it runs properly. You need to test whether your implemented code are correct, okay, according to the requirement. It solves the problem. Normally, we can divide testing into three groups or three types, right? The first one is the unit test. Unit test usually conducted by developers, the guy that implement this subsystem, this component, this function, this unit. It is a simple test normally, okay? What is the input? What is the output? Something like what you do during your first programming lab. Your teaching assistant might give you some assignments, okay? You write some code, you produce a result, takes in the input, produce a result, and the TA check whether the input and the output of the of your program works properly, works correctly, and with respect to the expected result. Okay. The next one is a little bit more complicated. This is called the integration test. When you want to make sure that two subsystems, two components, two functions, two classes, or more works together correctly. They need to be tested together, as we have seen in the previous slide. Okay, so if you connect the two subsystems like this, and this is it takes in the input, and this is the final output. You want to make sure that everything runs correctly. Either you can test these two information, okay, two pieces of data, the input and the final output, whether it's correct or not. You can do that. You input, for example, 2 plus 2, 2 and 2, and the entire thing is to add the two numbers together. You expect the result to be 4. All right. You want to make sure that the inputs and the outputs correspond to each other. Or you can just place the testing here and here and here and so on, just to make sure that all steps are being done correctly as well. You can do both ways. Usually, you wanna check each step if you want to make sure that if it's like mission critical, okay, the data has to be correct, and maybe you want some debug some step. Okay, you wanna if this result is like 3, you want to make sure that which one produce the result, which one is the culprit of the error. The next is the system test. All subsystems are integrated into the system, and the entire system is tested together to ensure that it meets the user requirements. Usually the system test in the user level. Okay, the user clicks something, inputs something, and the data pops up correctly. The user tests something, inputs something, and do something, and the UI shows up correctly. The data are stored correctly, something like this. So you don't care anymore at this level how things work together. You care just that the user can use this program properly. All right. The system test, okay, is typically followed by beta testing, or what we call the acceptance testing. We talked a little bit more about this. We talked a little bit about this earlier. Okay, the acceptance testing is conducted by the customer on the final release of the software. So when you do the system test, as I was saying, system test tests the system as a whole. It doesn't really matter how complicated the system is. All right, it's just that the user do something, expect some result, and that result is correctly given to him, or maybe not the result but behavior. All right, it depends on what the software does. And because this is system-wide testing, okay, you can adapt this, or maybe you can just use it at acceptance testing. We call acceptance testing because this is the test, all right, where the customer decide should he accept your work or not. Would he happy? All right, would he be happy with your work? Would he pay for your work? Because after the acceptance testing, the user, the customer, or your product owner accepts the project. All right, and then after the customer accepts the project, you can release the software to the public or to the end user. Okay, and usually after this step, you get paid. In testing phase, you try to make sure that your software product does what it is supposed to do. Basically, it has to pass all your tests. Yet, even though your software passes all test cases, it doesn't mean that your software works correctly, properly, right? So what do I mean by that? It means that even though the software works as you intended to work, all right, it still does not satisfy what the user wants. Let me elaborate a little bit more on this. Software quality, okay, refers to the degree to which the software product or the system meets specified requirements and user expectation. And this roots back to the step where you conduct the requirement elicitation. Maybe what you deliver, right? Maybe the entire program, entire testing and designing doesn't correspond to what the user actually needs. And it's also maybe when the user gave you some requirements, all right, he didn't really know what he want, or he thought he knew, so he told you to do something 1, 2, 3, 4, 5, and at the end you deliver 1, 2, 3, 4, 5, and bam, when you release this and when you user test the software, he realized that, oh, we missed step number 4.5. Step 2 cannot be done unless we have done that. We need to do that first, or maybe step 3, 4, 5 that we agreed to do. It ends up very difficult to actually do it. Okay, so in that case, the software is said to have low quality. The more closely the product meets its requirements and the requirements the customer needs, the higher the software quality. But see, there are two steps, and let me point out right here. The software products, the requirements, and the needs. The needs is the why. This is the what, right? So this is why you need to make sure that you understand why the user wants what they wanted. Because once you understand the why, you also realize that, hey, do you want to do this? Why do you do it like this? Why don't you do it like that? Okay, you can counter them. You can give them better solutions, get better process. All right. Anyway, a deviation from what the software is required to do is called a defect, and there could be many level of defects. Okay, first, bugs, of course, are defect. If the software contains no bugs, miraculously, okay, normally you don't have that, but okay, let's just say you have software is bug free. Well, it doesn't meet what the user told you to do, okay, or what the user or what the user planned to have. But yet another defect is that the user told you to do this, okay, agree with you to do this, and you deliver it. Yet it doesn't really solve the problem, or the solution is very, very difficult to conduct or to perform. In that case, I would say the defect too. After you deploy your software, you switch to maintenance. Software maintenance refers to the process of modifying, updating, enhancing software after it has been deployed or released. You can divide maintenance process into 4 categories. First, corrective maintenance. This involves fixing defects, bugs, or error. Next one is adaptive maintenance. This type of maintenance involves modifying the software to accommodate changes. All right. Mainly, okay, we refer to external environment or external forces, such as operating system upgrades, hardware upgrades, all right, or if there are some regulations that has been introduced and you need to comply with those regulations. This ensures that the software remains compatible or workable in the evolving environment. But I would also include the features or functionalities that also came from the users and the customer as well. The next one is the perfective maintenance. All right. This involves the enhancements or improvement and optimizations that are not related to fixing bugs or defects or adapting to changes. This can include adding new features or to improve user experience, optimize algorithm, optimize reliability, okay, or scalability. Last kind of maintenance is preventive maintenance, or sometimes it is called proactive maintenance. This kind of maintenance involves making changes to the software to prevent potential issues or problems that might occur in the future. For example, code refactoring, performance tuning, and security improving. Now that we know in detail what do we do, what are the activities in each of these steps, all right? And this cycle, okay, including the steps inside, it is quite well known. All right, if you open any textbook in software development, computer science, software engineering, you're gonna see a similar cycle, this software development life cycle. The question is, all right, right now, the question we're gonna focus is how do we schedule these phases, these activities? We need some guideline. Okay, we need some guidelines such that it guides us to develop the software, all right, that is the most suitable for the applications or the users that are going to use the product. And this is what the software development process actually is. It is a framework that defines the order and frequencies of these development phases or activities. Okay, it provides the guidelines for all the people involved in the software project. Okay, what to do next? What should I produce in this step? Who should be involved in these steps? Okay, and who should take over the work when I finish my activities? And later on, we will see that by adjusting, improving these development processes or steps or activities, we can also make the software. It would also improve our software in the way that it is easy to use, less bugs, and correspond to what the user actually needs. Okay. And we call particular software development process, okay, or the specific process implementation, we call it software development process model. And we're going to have a look at a number of these models within the course. So why do we need software process? I mean, why can't we just follow normal engineering or construction process? All right, requirement engineering, design, developed, release. Okay, because unlike other engineering or development problems or building, constructions, bridges, car making, city planning, gardening, all right, software development changes occur constantly. Requirements may be changed and added any time. Maybe before the release, in the design phase, okay, or even after the release, after the user uses it, and then somehow they realize that, hey, this is not what we want. Maybe we want something more. We want something else, and therefore changes occur all the time. To be fair, in other engineering problems, changes might occur too. All right, you build a bridge. Okay, it is too narrow, but when you realize that the bridge is too narrow, you just have to live with that. Okay, the bridge is too narrow. The traffic doesn't flow so well, or it doesn't flow as well as you thought it would. You just have to endure it. Okay, you can't do anything about it. You can't just replace the bridge. But in software, the user has a different mindset. They were like, oh, okay, this is too small. The font is too small. We're gonna add some more data into our database. We need to instead of email address, we also need that mobile phone as well. Something like this. And this kind of thing, the user will not just say, okay, we will endure it. Or sometimes they do. Most of the time they don't. Most of the time they want what they want, and they ask you to do it because it is much easier to change than rebuilding the bridge. All right. And frequent changes are very difficult to manage. Okay. The planning and cost estimation are difficult because when you quote the price, okay, this thing gonna cost 1 million to develop, and suddenly new things shows up, and then okay, we also want to take this thing out as well, and cost of taking things out, well, most of the time it's not free. You need to do changing, right? Even though it is taking out some features, but you need to change the software to remove those features. And also there could be more than one versions of the software system to consider. All right, we have this system under development. Okay, the version that you are working on right now, the new versions, and the released system, the current version. Well, what do I mean by that? For example, you release software to manage your convenience store already. Okay, it is up and run. The cashier can receive payment. The customer can buy products. All right, the manager can manage the stock whatsoever. And that's the released version, the one that the version that is running right now. But on the other hand, you also try to develop another version that is the improvement of the current version. It could be just the small releases, or it could be the big version, kind of complete revamped of the previous one. In this case, you have two software versions to maintain, all right? And maintaining just one version is hard enough. You need to maintain two versions. We need some guideline, all right, that allows us to do this as well. There are several software development process available right now. Okay, for example, Waterfall. We have seen that last session. Spiral model, agile processes. All right, each of these processes are designed for different purposes and project attributes. For example, the project size, the time, and the knowledge about your application domain. For example, if the project is small, okay, like 2 weeks, 4 weeks, or even 2 months long, sometimes Waterfall would work. You collect the requirement once, okay, you design once and you develop once, and then you release the software immediately. You don't have to repeat the process. You don't have to use the iterative and incremental models because the project is so small. Chances of the changes are low, and you don't have much time to show and let the user test anyway. All right, and something like automated testing, continuous integration might not worth it to be applied, to be used on the project that is small, okay, in both size and time, because setting up this tool takes time as well. Okay? So you need to consider all this, and the domain knowledge. Of course, the project that is known, like when you develop software that control space stations, or maybe the ground control station, then you don't want to change anything very much. You need to know everything beforehand. You have to invest a lot of time in requirements collection and designing before you actually start coding, because nothing can be wrong. All in all, there might not be the right method. Okay, sometimes you just want everything to be solid. Sometimes you want it with your software to be flexible and adaptive, easy to change. All right. But before we discuss further in the development process, let's have a short look on who and what are involved in ordinary software development. Let's talk about the 4 P's in software development. The first P is people, group of people that are involved in the project. Sometimes we call them the stakeholders. Right? The other one is product, software product that you are building, as well as the documentation, manuals, video, anything that are related to the products. And then the project, okay, is the activities that are carried out to produce the product. And then we have the process, the framework that the team used to conduct the development activities. That is the software development process. So let's have a look in details what these 4 P's are about. First, the people. These are the ones that are involved and have some stake in the project. That's why we call them the stakeholders. All right. First, it is the business people, business management. They are responsible for the business side of the project or your software company. Okay, they may or may not have the technical knowledge, but they do know about the business. They can set aside the budget. Okay, they're gonna have a look whether the project is going well financially. Okay, how would we develop the business model out of the project, and why how much money could we make over time, and so on. The other one is the project manager or PM. Their task is to plan and track the project, how well the project is going. Okay, keep the project on schedule and within the budget. Project manager needs to know how to work with people. Okay, but they don't really need to have strong technical knowledge. Right? That is not what they're supposed to do. the developer, the dev team is supposed to have strong technical knowledge. The project manager needs to know what to be done and when, okay, and are we over budget or not. Still, ideal project manager for the software development projects supposed to have technical knowledge as well, because when they meet the customer, when they get the requirements, all right, when they decide, okay, this thing should be done first, or this thing would take like this like 4 months, 2 months, or a few weeks, they're supposed to be able to measure that or gauge that, all right, based on that technical background. But I need to warn you, all right, not all project managers have strong technical knowledge. Now let's move on to the development team or the dev team. Of course, the task is to develop and maintain the software, and they have strong technical skill. And of course, we have the customers, the guy that pays for the project, okay? He may or may not be the one that use the software, okay? I told you already, okay? These are the guys that can decide whether the software works or software doesn't work, pay or not to pay. But they are not, at the end, not the ones that use the software, or maybe they use part of the software, but not all of them. They could be executives that just want to see the annual report or monthly report, but the guys that have to work daily with the system, the guy that's produce the report, the guys that input the data, all right, that could be other kinds of users. And we collectively call every user the end user, all right? And when you develop, okay, you want to make sure that you satisfy end users, not just the customers. Customer, of course, because they pay, but the end users are the most important persons, because they are the one that use your software. If they like the software, then it means that the software is of a high quality. Next is the product. Okay. Products refer to anything you produce during your project. Okay. A software product is usually called artifact. All right. The artifacts could be the code themselves, of course, because you are developing software, you need to write source codes, you need to write codes. And the code could be the source code, of course, the one that you just wrote, and then the compiled code or object code. All right. And maybe some other form of digital assets that you need to deploy on the server or the user devices. But not just that. When you release the software, you might need to produce the documentation as well. For example, user manual, video tutorials, or any other documentation that you need to submit to the customer. And that is your customer documentation. All right. But apart from that, you also need documentation within your team, within your development process as well. This is what we call the project documentation. Either this is task list, product backlog, system models, UML, any kind of support elements, okay, or support documentation called project documentation. To summarize, we talk about everything you produce during your development. Next, we have project. Here, we are focusing on the management and governance of the development effort. Okay, the project usually includes the project planning phase, resource allocation, human resources, technical resources, computer, all right, and maybe even office spaces has to be allocated. Scheduling and budgeting, you need to set the time, you need to set your budget, how much you want to spend, how long the project should take. Project management ensures that the development process is organized, controlled, and completed in time, in budget, and with acceptable quality. Okay. Normally, the project manager or PM is hired to do this, but the task of making sure that the project runs smoothly is responsible by everyone, every stakeholders in the project. Some some smaller teams, they don't even have project manager. Okay, the team is self-organized, and this is what we encourage people to do. Okay, in some of the agile software development process like Scrum. Okay, the team's supposed to be self-organized. You don't have anyone to come up and tell you that, okay, you do this, and you need to do this within 2 weeks, or you need to do this within 2 hours or 2 days. All right. Lastly, the development process itself. This refers to the methodologies, practices, procedures that are employed during the software development. It encompasses a series of structured and disciplined activities that guide the development team from the planning phase, the inception phase, to the final deployment of the product, and also the maintenance phase of your software product. This includes selecting the development methodology such as Waterfall, Scrum, Kanban. You don't have to know all of them right now, but we are going to discuss each of them during this course, right? And then how and when to collect requirements, to design your software, to design each component, to implement and to test them, how and when to deploy and maintain the software product. Okay, and then how to improve the product and the process itself. Effective management of the process phase ensures that the software development process runs smoothly and successful. Okay, see, I have highlighted 2 words here: structured and disciplined. For example, you decided that, okay, we're gonna use Waterfall. Okay, step 1, collect requirements. Step 2, design. Step 3, implementation, and so on. Whatever you do, okay, once you decide this is how you do it, you have to be disciplined. You need to follow that. Okay, you cannot be lazy. You cannot miss any steps. You cannot just skip them. You cannot say, okay, you know what? After each step, we need to write down. You need to write the after you create some part of the software, you need to push the code into Git repository, or any new requirement has to be added into product backlog. Any task it has to be done must be added in your task list. If you skip all this, all right, then you're not following your plan. You're not following your guideline, and then in the end, you keep track of how you do, or what you do. What am I doing? When should I do this? What should I do next? Okay, then the project wouldn't run as smoothly as it should be. Sometimes even fail. All right, we're gonna learn during this course a lot of software development methodologies. All right, and I want you to focus. And once you employ any of these, all right, you might not even need to employ the entire package. You might want to employ just, okay, this part I will take. I will use this part from Kanban. I will use this part from Scrum. All right, you can mix and match anything. But once you settle, all right, once you decide what you need to do, how you're going to do it, you need to stick to the plan. You need to be disciplined. And I talk about this directly from my experience. Okay, once you get lazy, everything gonna fall apart. Now, let us introduce ourselves into some SDP models. The first is a group of models. We call it sequential models. Sequential models execute each phase or each activity in sequence. Activity 2 will always come after activity 1. Activity 3 always come after activity 4, and so on. You will not skip any steps, and you will not do anything in parallel. It is clear and precise. Okay, the procedure is quite clear. 1, 2, 3, 4, 5. You will not skip. Okay, so it is easy to manage. At the end of each step, or at the end of each phase, you can decide, okay, you can check, okay, we have done this, perfect, okay, and then we can proceed to the next step. Okay, we have done this, perfect, okay. If not, then move back and then fix it. If you have done that, move on to the next step, and so on. Because it is easy to manage and easy to understand, it is also easy to quote prices and cash out. You can decide, okay, when we finish requirements gathering, we will catch 10% or 20% of the budget first, and then after you implement, after you design, you catch out another 20%, okay? And then the customer going to pay another 40% after you finish implementation, and after you deploy, or after you test, that you pass all the UAT tests, or the user acceptance test, the customer going to pay the rest. So it is quite easy for everyone, for project manager, for you to decide, okay, I'm done, or I'm not done, or I'm not done yet. Okay, and for the customer and the user as well, the customer can expect the result at the end of each phase. The most classical one is the waterfall model. We discussed this already last session, but let me get you some recap here. All right, waterfall model define each software development phases in waterfall structure like this. All right, starting from requirement engineering or requirement gathering or requirement elicitation, and then you move on to architectural design. Okay, you design the big picture, then you move on to the detailed design. You design each component, how what kind of algorithm should be used, and so on. And then you move on to the implementation. Okay, and then testing, and then maintenance. See, if you have a look at this, at the first, in the first 3 steps, 3 phases here, okay, you need to get all the requirements and design done. You need to know everything by this point, okay, before you start coding. You need to know every aspect of your software already. You can also add some small testing steps right here at the end of each phase. You check, okay, you kind of test and make a small check whether, okay, have we collect all requirements, all right, have we talked to all kind of users, all right, if this design correspond to what user wants, okay, can it handle the traffic, can it handle all the features that you want to do, and so on and so forth, okay. But in the end, everything about your project, everything about your software is known right at this point. And once you implement, okay, you do the checking again to make sure that whatever you do, it doesn't diverge from what you plan to do, okay. And if it does, maybe you feel some, you see some bugs, you miss some features, this feature doesn't perform as it should be, then you move on to the previous step, the detailed design. And if the detailed design cannot solve, okay, somehow this component is there, but it shouldn't be there, we require more component, then you might need to go back to the architectural design to kind of redo or fix some architecture that you have designed earlier. But maybe even though you come back to this point in architectural design, all right, you might find out that this something in this architecture, okay, doesn't answer or doesn't correspond to some of the user requirements, and you might need to change this design. But it could be that in some of these steps, you know that you miss something in the requirements gathering. Oh, you miss this feature. We haven't talked about this feature. We haven't talked to this people. Okay, we haven't talked about with this user, and we need to know more. Then you need to come back at the requirement engineering. All right, and then you might need to redo your architecture again, redo the detail design again, and so on. All right, and see, it goes like this. So at the end, all right, maybe some flaws here. You might know at the end, right here in the testing or even the maintenance. When the software runs, you realize that, oh, this architecture doesn't handle a lot of people. Then you might need to come back and design the entire thing again. Okay, so even though it is clear, each step, okay, has a clear goal, has a clear set of tasks, has clear artifacts you need to deliver, and you can also catch out too right here. Okay, we have done that, we got your money. All right, but errors and changes are not friends with waterfall model. Okay, if you detect error here, oh man, that's bad. If you realize right here, okay, at this step or right here, that you need to change something, that your requirements are not have changed or haven't covered some aspects of your user problem, then you need to redo everything all over again. Okay, so some people say that waterfall is obsolete because it cannot handle changes at all. It cannot handle emergent requirements, new requirements that have been emerged recently. Okay, it cannot handle scalability or some unforeseen characteristics or requirements that you haven't thought of during these design phases. Some people say it's obsolete, but I say is it not? Okay, it is still useful. Waterfall model is useful for small projects because the requirement set is small. The chances that they're going to change would be also low. And even though you need to come back to change anything right at the beginning, at the top right here, it wouldn't cost you too much because the project is small anyway. It is also quick because you can just set aside, okay, if the entire project is 2 months, you can set some time like, okay, in 2 weeks we need to finish this, and then we're going to spend another month, like 4 weeks to do this, and then another 2 weeks for testing and producing manuals and other kind of artifacts, right? So don't throw out Waterfall just yet. Sometimes it works. Okay, another one that Waterfall works best is the project that you know beforehand what you want and you cannot change it. The example that I always use is building software to control a satellite or ground control program. These kind of things, you need to spend a lot of time planning, all right, before you actually implement it, because it's going to be costly to change, all right? And you can't just, change the software or just do day one patch when the satellite has been launched. You need to make sure that everything is running. You need to make sure that it will run, and you need to make sure that it is running before you even start launching. Also, waterfall model, all right, even though it just doesn't handle well with changes, it also serves as basis for newer models, because each of these steps, each of these phases are kind of common activities that you should do in software development anyway. The next sequential model is V model. V model is a software development model that emphasizes structured and sequential approach of software development lifecycle. It is called V model because of the V shape here that explains the relationship between each phase, okay, and the corresponding testing phase right here. V model highlights the importance of testing and verification throughout the entire development process. All right. See, we have this unit testing, integration testing, and acceptance testing. Okay. Requirements in engineering or requirements elicitation correspond to acceptance testing. Architectural design corresponds to integration testing. Detailed designs correspond to the unit testing. Here, in the first step, in the first testing step, the unit testing. Unit testing performed on each and individual module or component or subsystem to ensure that it functions correctly in isolation, so it works perfectly alone, right? In this testing phase, it verifies the functionality and behavior of individual components that correspond to the detailed design, because you design each component individually. All right. The next testing step is the integration testing. Integration testing follows the unit testing phase in the way that it involves combining the tested modules and verifying their interaction and interfaces. The goal is to identify and resolve any issues or inconsistencies that occurs or arise during the integration process, and to make sure that all components are integrated smoothly, nicely, correctly. You need to make sure that your architectural design is correct too. So architectural design corresponds to the integration testing. And last step of testing is the acceptance testing or user acceptance testing, or UAT. In this acceptance testing, okay, or you can just do this in the system testing step as well. In this phase, okay, you test the entire software as a whole. It ensures that the integrated system meets the specified requirement and functions properly. This phase includes functional testing, performance testing, usability testing, and other form of testing. Okay, but again, it tests the entire system, and therefore correspond to the requirements elicitation, because you want to make sure that the software as a whole answer to the user's problem. We model, even though it's shaped like we, but you need to do in sequentially anyway. So step 1, 2, 3, 4, 5, 6, 7. All right. Maybe you're going to repeat this step a lot because you need to check, implement unit testing, but it corresponds to the detailed design. All right. But anyway, after you finish this, you're going to go into testing and acceptance testing. We models emphasizes the relationship between each of the design and development phase and the corresponding testing phase, making the testing an integral part of the development process. It promotes early identification and resolution of issues or problems that might emerge, reducing the risk of late-stage defects. However, it is important to note that because we model is sequential model, is suffered pretty much the same problem as Waterfall. All right, if you have some emergent requirements, if you have some changes late in the development, you might need to trace back, okay, through the beginning, and it could be costly. Now let's summarize pros and cons of sequential models. Sequential model, it is simple and easy to use, okay, because the phases are well defined and executed sequentially. It is also easy to manage. The model is rigid. You know what you need to do. You know what is the input. You know what is going to be your output, okay. Each phase has specific deliverables and review process. You need to know what to check for at each step. It also facilitates the allocation of resources because different phases require different sets of personnel. This design phases, you need the business analyst. Next step, you need system analysts. Next step, you need developers. Okay, and these personnel require different set of skills. So allocating resources for each step, it is quite clear and easy as well. It works well for the project that requirements are well understood. All right, short and clear projects are ideal. But let's say some cons. The requirements must be known beforehand. Everything must be known in the requirement and the designing steps. All right. It doesn't work well with the project with hazy knowledge. So if the customer are not sure, all right, the users are not sure, okay, we don't know what should we do with this. We're gonna leave the details later. We will decide later. Something like this doesn't work well with waterfall or V model or sequential models. And there is no feedback from stakeholders because in the requirement elicitation phase, the design phases, the implementation phase, you are not showing anything to your users and customers just yet, okay? And therefore, because they haven't tested, they haven't seen it, they cannot get you feedback, okay? And that could lead to a problem because after you get feedback, negative feedback, all right, then you need to come back and fix something. That is, the problems and issues of the projects might not be discovered until the testing phase, which is already late. It also lacks of parallelism, okay? What it means is that if you are in phase 1, phase 2 cannot begin yet, phase 3 cannot begin yet. You cannot do anything together. See, let's just come back to this. In the pro, okay, we say is that sequential model facilitates allocation of resources because you need different kind of people at different time. But what if you have two sets of people, system analysts and developers and maybe testers available at hand? Why don't you let them work at the same time? Developers don't have to wait until the SA finish their work. The tester also don't have to wait until the developer finish their work, right? You can make them work together at the same time. And if you follow sequential models, that would be difficult to work in parallel. That leads to the last one, inefficient use of resources. due to the lack of parallelism, okay, team members, developers, SA must wait until the other team, okay, finish their work first, and that is a waste. And you might be asking, okay, what do they do? Because waterfall model has been used for a long time. So the way the big companies and only big companies can solve is that, for example, at this step, the system analysts, okay, interview the customer, the dev team is free. You can allocate the development team to do some other project first. And once the SA finish their work, the design is done, requirement is done, the developers can just come to this project and work based on the set of requirements and design, and the SA can be moved to other projects. But then you need a lot of projects running, all right, going on at the same time, and it also makes the project management and also cross project management a little bit difficult as well, because if in your current project, okay, SA finishes the work already and every design is done, and development team is still stuck in other projects and cannot move to this project just yet, then this project comes to a halt, right? You don't want that. It is very inefficient. And how do we fix this? Okay, we're gonna discuss iterative and incremental models and agile models, and then we will see that, okay, today software development processes aim to address all this disadvantages of sequential models. One of the solutions to address the issues of sequential models are the iterative and incremental models. Iterative and incremental models are software development approaches that emphasize a cyclic and progressive development process. It involves the repeated iteration of development and testing activities, allowing for continuous improvement and incremental delivery of working software. This model, all right, allows you to be flexible, adaptive, and it also allows the incorporation of user feedback throughout the development lifecycle. It starts with small portions of a software project and then repeatedly add new portions into the project. Incremental refers to add on to something. All right. Here, the software is developed and delivered incrementally, with each increment adding new functionalities and improving upon the existing features. Each increment is a usable and deployable subset of a software system. What it means is, after you add some features in that, you can't just say, okay, we are working on it. This feature has to be complete, okay? And the entire software has to work as well. So you have a working, you have a small version that works. You add something new, okay? The entire thing, that including the added part, must also work. And then the increments are delivered to stakeholders and users for their evaluation and feedback. Okay, here the users and the customer get feedback even from the small piece of your work. It could be just small part, right? So you show them, let them try, you get feedback, and if there are anything to fix, you will be able to fix it early. Iterative means redo. Okay, so the development process is divided into multiple iterations or cycles. In each iteration, it consists of a complete development life cycle. It means that from requirements elicitation, design, implementation, testing, and so on. Each iteration results in the potentially shippable increment of the software. And again, at the end of iteration, you're supposed to show a working product, okay? We call this potentially shippable. So it should be able to ship or should be able to deploy. The duration of iterations is generally fixed, okay? It is predetermined to be 2 weeks, 4 weeks, a month, 2 months. It doesn't matter. It depends on the size of the project, on the manpower, but it has to be fixed. The feedback and lesson learned from each iteration would be used, okay, to improve your working process or the product in the next iterations. And because you keep doing, you keep adding small things in cycles, you add and you add, you incrementally add something in and get feedback early. It means that iterative and incremental models is very flexible, all right? And it also reduces the risk of having or collecting wrong requirements, or having some issues that can that will be detected at the end of testing or the actual delivery. Okay, it also allows for rapid prototyping. Iterative cycles enable the creation of prototypes. We're going to talk about that in the next few slides. All right, rapid prototypes and early validation of design and functionality. If there are issues from the in these steps, you will be able to detect early on. Still, iterative and incremental models are not free from disadvantages. All right, there are some challenges. For example, to manage the scope, ensuring that the scope of each iteration is well defined and manageable can be challenging to avoid what we call the scope creep. So it basically works like this. You show the customer something, all right, small versions. They get feedback. They want something more. They want to change something. You accommodate the change. You in the next iteration, you show them again. They keep getting your feedback. Oh yeah, we want this too, and so on and so on. And then you incorporate the feedback, and then they can be like, okay, oh yeah, but this is nice. But can we add that also? See, now you keep adding things in. You need to also control the scope of the software as well. And I'm talking to you right now based on my direct experience, all right? Once the customer see your product, they will have feedback, good and bad. I call bad feedback when there's something wrong. Okay, this is not what the user wants. They don't want this. They want some other thing. The UI is bad. They can't understand, something like this. But good feedbacks are, yeah, these features are what we want. This is perfect. Okay, and then good feedback could lead to some other kind of feedback as well. It can't replace. Yeah, this is awesome. We want this, but can we have that as well? All right. Sometimes they just haven't thought about that before. But once they try, all right, or they use the product, they see the prototype, they were like, oh, okay, we have another idea that might work as well. Or we would also have that, because this is good, but we could make it better. Still, all right, even though you want to avoid the scope creep, you still have to see, you still have to show them to get early feedback, because it is easier to control the scope than to fix something that you haven't noticed before. Another challenge with the iterative and incremental model is integration and testing. The iterative and incremental approach requires careful management of integration and testing activities, because you keep adding things in, right? You keep changing things. You need to make sure that overall system stability and functionalities are intact, even though you add some changes, add some new features. Another one is documentation. Continuously updating and maintaining documentation throughout iterations could be painful. You need to change the user manual, you need to change the design, you need to change your use cases, you need to change the task list backlog, something like this. So that takes a lot of effort also. Iterative and incremental models are the fundamental, okay, concept of agile methodology, such as Scrum, Kanban, less, right? We will talk about all this later, but the idea of being agile, idea of agile development came from the concept of iterative and incremental model. But before we get on to agile, let's have a look at some examples of the iterative and incremental models first. The first model that we are going to discuss is the spiral model. Spiral model is the software development model that combines the elements of iterative, okay, and waterfalls together. It was proposed by Barry Boehm in 1986 and is widely used in situations where the requirements and risks are complex and uncertain. Spiral model incorporates the iterative cycles in the development, and in that it also emphasizes the risk analysis and evaluation to gradually refine and enhance the software product. As you can see in the image here that I took from Wikipedia, this is the image of spiral model defined in 1986 by Barry Boehm. All right, it consists of 4 sections. All right, 1, 2, 3, 4, and each section we call a phase. Okay, the first one is the determine objectives, or I would say a planning phase. This initial phase involves defining the objective, scope, and constraint of the project. This includes identifying the requirements, project risks, and resources that will be needed. All right, and then once we have this plan, when we have this in hand, we're gonna move on to the second phase, the risk analysis, or identifying resolve risk. In this phase, the potential risks and uncertainties related to the project are identified and analyzed. Risk analysis helps prioritizing the risks based on their impact and likelihood. Okay, what are the chances that this risk could happen? All right. Also, the strategy to for the risk mitigation and the contingency plan it should also be developed. Now, you might be thinking, so what are the risks that we talk about here? For example, that could be anything that could happen. All right. What if we are going to use new library? Okay. What are the risks that this library might not work? What are the risks that this library gonna be deprecated? Okay. What are the risks of the software would fail? What are the risks that it wouldn't scale? All right. You need to have a look at. You need to think about the chances that things could go wrong. All right. What are issues that we should be worried about, and what are the chances that it would happen? All right. And then we move on to the phase 3, development and test, or sometimes we call it engineering phase. In this development phase, all right, it involves developing and implementing as well as testing the software based on the requirements and design specifications that we got from the previous phases. It follows the iterative approach, with each iteration adding new functionalities and enhancing existing features. All right. And then moving on to the last one, plan the next iteration, or the evaluation phase. In this phase, we focus on reviewing the work that we have done so far, okay, assessing the quality and the completeness of our software. This involves various forms of testing. Okay, you can do the integration testing, unit testing, and so on. You can also get the user feedback and verification against some requirements. All right. The evaluation phase helps us in identifying new deviations, error, and any issues that has to be addressed. I wouldn't bother you with all the details here. They're not very important. But the idea is that at each phase right here, see this, it's called spiral because it's go out and out and out. And take a look at this x-axis here, cumulative cost. Okay, because the more you know, okay, the more you know about your hardware, the more you know about your requirements, the more you know about the features, the more you know about the risks, the cost that has added into development increase. And also, okay, the set of features increased, set of functionalities increased, all right, set of document also increased. Each phase gonna get larger and larger and larger. And of course, the you might need some time to think about the risks. The risk gonna get higher too, because there are a lot of artifacts that you produce, a lot of requirements that you need to follow, and therefore this cycle got larger and larger and larger. Now, what I want you to focus on is this section here, this phase, risk analysis phase. Okay, here you identify and resolve risks. Risk analysis is one of the key features of spiral model. All right, it dictates that before you actually do anything, okay, you want to make sure that your plan is feasible. You want to make sure that your plan has some risks. If there are something that could go wrong, you want to identify them first. See whether should we go on or not. How many chances that they're gonna happen, and if it does occur, how bad it would be. All right. But we're gonna discuss risk management in the next few slides. Right now, okay, I want you to focus on here, this section right here, the gray area right here. Prototype 1, prototype 2, original prototype. Prototyping is one of the tools that we can use to mitigate risk, to reduce the risk. If you don't know whether this UI would work or this kind of new user interface would work, you might want to build a Figma first, or just draw some paper on some paper and let your team and let your user or customer discuss. Figma is a good tool to do UI mockup, right? Because you can also interact with the UI. It looks pretty much like the real thing. Okay, but we're going to talk about prototype later on as well. Once all the risks are identified and determined, you can work on your project. You can move on and follow the normal iterative step later. So what is prototyping? Prototyping is a process of creating a preliminary or partial implementation of the target product. It is also a risk management technique. Okay, it can be used to identifying risky parts of the project. Okay, it can be used to determine the idea about the customer requirements and gather look and feel in the GUI. Okay, well, let me elaborate a little bit. Here are some key aspects of prototyping. First, you can use it as the exploration and validation aspect. Okay. Prototype can be used to explore and validate ideas, concepts, or requirements. They help the stakeholders and the development team to gain better understanding of how the software should look, the feel, and the behavior. Okay? And here, you can use it to facilitate the requirement elicitation by providing concrete representation of the software that the user can see how it should look like. And sometimes the user can also interact with the software and see, okay, this is what I want. This is what I don't want. Okay. It helps identifying any gaps and any misunderstandings of the initial requirements and support the process of refining and clarifying the requirements further. And then you can also use prototype to get the design feedback, right? The prototype allows the user and stakeholder to provide early feedback of the software design, the user interface, the user experience, overall generic idea of your software. This feedback can be used in the design decisions and to improve usability, to improve functionalities, and so on. Here are examples of prototypes. First, illustrative prototype. Here you are trying to create a mock-up of user interface and maybe set up storyboards with a workflow. Okay, you see this screen, you see next screen, you see next screen, and so on. You can just write it down into a napkin. Okay, if you discuss with your customer, okay, and you want to make sure that this is a thing that we want, you can draw it on a piece of paper, or you can just use the UI design tool like Figma to do it. It is very good for early client discussion. You can also do two things, okay? This kind of illustrative prototype, okay, you can also divide them into two categories. The first one is the low fidelity or low-fi prototypes, okay? These are basic, rough, and quick representation of your software system. And you can also do the high fidelity or high-fi prototypes. These prototypes are more detailed and closer to the final look and feel of the software. This may include the interactive interfaces, simulated functionalities, visual elements. You want to show that the user can type in something here or input some data and it shows it to a report or graph, something like this. Another kind of prototype is functional prototype. Okay, well, here you actually implement something. You want to make sure that your idea works. You want to make sure that this part of the software that you think is very difficult to implement, or the customer could have the requirements or some problems, all right, that, okay, we want to compute this and that, all right, and we want this kind of output. You're not sure that you can do this. Then you are going to focus on this particularly difficult problem and develop a software to solve that first. All right. If you could do that, then, oh, okay, we have done the prototype of the difficult part, and I think the rest we can do it easily. All right. The other one is the exploratory prototype. Okay, you explore thing or a hack. You try to implement part of the system or re-implement part of the system to learn more about the requirements. For example, normally you're using bubble sort. I don't know, it's a bad example, but bear with me. You normally use bubble sort to do things, all right? And you're gonna be like, oh, okay, why don't we use quick sort instead? How about that? All right. Or normally we use array to store student data. It is very hard to find student. Okay. How about we use other kind of data structure instead? And you're trying several data structure or several different kind of searching algorithms, and you pick the one that is more suitable for you. Okay. All this, you are not focusing on the the actual working software, but you are trying to attack smaller problems. And this kind of prototypes help managing the risk, because there are some risky part that you think, hey, it could be an issue, it could be a problem. Why don't we just solve that first? Now you know what prototype is. All right, prototyping is one of the most important steps in the in spiral model. So let's discuss the pros and cons of spiral model. Let's just start with the advantages first. It is fast development. Okay, risks are managed throughout the process. Okay, you can just start with smaller iterations, and then larger and larger and larger the software start working. All right, you have the working software since the first iteration, and you add something in, you add something in, you add something in. The planning, okay, is integrated into the process. So at the end of each spiral, and when you want to start the next spiral, next iteration, the first thing you need to do is you plan, and then you do risk analysis, right? See, being, doing the risk analysis, that's the main disadvantages as well, because risk analysis requires an expert, okay? Expert in the domain of the user. So you need to the guy that identify risks must understand what the user are doing. Okay, what would be what this software is supposed to solve. Okay, they basically have to understand the problem. Then he has to understand the solution as well. He has some technical background, so that he can see that, okay, if you implement it like this, you're gonna end up in the with a lot of problems later. Okay, therefore, risk management is expensive and might not be necessary or for small projects, or might not even be feasible for smaller projects. Still, spiral model, even though it's iterative, it cannot handle changes very well, especially the emergent requirements, some requirements that just occur late in the development, right? And because you have to do risk analysis, you have to do planning, all right, you might end up generating tons of documentation, all right? And as I was saying, documentation takes time, okay? Since we did talk about risks, why don't we elaborate a little bit more about software development risks, all right? Software development risks refer to uncertain future events that may cause loss to the software project. What it means is what could go wrong, right? So identifying risks is a very important task. You want to know beforehand what could make your projects go south. Software development risks could be divided into 4 types, all right? The first one is schedule risks. The other one, next one is the budget risk, operational risks, and the last one is the technical risk. Schedule risks refer to time-related issues, right? So something that could make the projects delay. Delayed development could cause financial and sometimes reputational loss to both you, okay, and of course the customer as well. You want everything to finish in time, right? Well, and missing the target date, it means missing opportunity, and sometimes you can the developers can get fined as well. Well, schedule, right? Refers to time or delay. It is not just that the project is delayed and you lost opportunity to use the system in time, all right? It also means that for some projects, it cannot be delayed, all right? So for example, if you want to release a game, all right, and you want to release around Christmas time so that you can sell, right? And you miss that. So and then you if the game is if the development is going slow, then you miss the selling time or the holiday period where you can sell your game. Well, that sucks. But for some project, it is not just that. Some projects you need to use the project in time. For example, the software that manage the election day or the vote casting, right? The software that manage the student enrollment. If you miss this, enrollment season, you're gonna wait until next year, for instance. And for election, it's even worse because the national election comes normally in every 4 years, right? If you miss this one, then you can't use that anymore. Therefore, for some projects, time is of essence. So what could cause delay? First, improper effort estimation. Right? What it means is that you know what you need to do, but you think you need less time to do them. Inadequate requirement elicitation. Features and completion are not well defined. Though these two pretty much come together, right? When you collect your requirement, you haven't collected well enough, and there could be some requirements missing, all right, or sometimes you thought you understand already, but you don't. Okay, sometimes there are hidden issues or some hidden requirements or some hidden things to do, and you didn't figure them out early, and you figure out later that, oh, we need to do that too, and that these kind of extra works you haven't accounted for earlier, right? Sometimes requirements come later, emergent requirements, something that occurs during the development or after the development, all right? Sometimes we have just new requirements from the user themselves. Sometimes there are some other forces, external forces that make you change something, all right? And these unforeseen requirements, well, I would say unavoidable. Right. So these 4 points are all about requirements and estimation. All right. Sometimes you are in some unfortunate events you cannot know beforehand that such requirements would happen in the future. But here, see this line last points here: poor resource allocation and tracking. Understaffed staff quit the project or quit the company. Team members are being allocated to other projects. Developer skills do not match the tasks. Deploy tools, both hardware and software, are not suitable for the tasks. These points, all right, it is about your resources and skills. Even though you know that you know precisely what you need to do, okay, you have allocated resources properly, You have some, estimated your effort properly. Okay, I have this much to do. I require so much time, but something like this happens too. Some people quit. Some people die. They got pregnant. Or they got sick. All right. Then these resources are simply missing during the project. Okay. Or in some companies, there are some more urgent projects than the developers or system analysts or some personnel must be relocated to other projects, and it sucks, but it happened, and you cannot really know that beforehand also. Okay. But sometimes the developers themselves, okay, they are forced to work in some project or some platform that they are not familiar with. All right. For whatever reasons, and this could cause some delay, because if they're not familiar with the tools, they're not familiar with the domain, the estimation is going to be much more difficult for the team, right? And the tools that they use, okay, sometimes they don't match for the task. They're not suitable for the task. That could happen for many reasons. Maybe because the customer's environment are like that. The entire customer company use some platform, all right, and but somehow that is not very suitable or very difficult for you to work on. Next one is budget risks. Budget risks relate to money. Okay, so you want to make sure that you have enough money, okay, to finance your project, and from the start to the end, right? That mean, but also which could mean two things. First, do we set aside enough budget to complete the project, and then we thought about and after the project is completed, do we have the budget to maintain it, and can we still profitable from our product? The cost of budget risk, okay? Inaccurate cost estimation or budget calculation. Simply put, you think you need 100 baht. In the end, you need 120, 150, or maybe 200 baht. Right? Emergent requirements and project expansion or product scaling. Same thing, all right? You have some requirements that emerge later, and you cannot you cannot unforeseen it, or sometimes the project is going well, all right, or maybe there are some other forces that requires you to do something more. It could also caused by simply mismanagement, right? Using money incorrectly, poorly managed cash flow, for instance, and improper budget tracking. So when you spending on your project, whether it is for software, for the development costs, for the other expenses, you didn't keep track of them well enough, and before you knew it, you were running out of cash. Next one, do not have financial backup for budget overruns. What it means is that you set aside budget for say 100, all right, and somehow the budget costs 150, and you don't have second pocket, all right, in storage. Okay, so basically you don't have plan B, and once the budget, well, once your project goes over budget, you cannot fund your project anymore. Lastly, you count on future income. What it means is that you expect money to come in the future. You knew that you're going to need 100 baht to complete this project. Right now you have only 50 or 60 baht, all right? And you expect another 50 to come in the future, either from joint venture, from an angel, from other kind of investment, but it doesn't come as planned. Then you simply run out of money during the project. Operational risks. Operational risks refer to day-to-day activities or tasks. All right. There are issues that could cause development delay, or some ineffective development process. These include management, communication, product deliveries, and so on. Such issues are usually overlooked during requirement recitation and the design phases, because in those phases you are focusing on the problem, you are focusing on what to do and how to do it. All right, but you didn't think about what is the process of implementing it. Cause of such risks include the inadequate task management or task planning, all right, unclear roles and task assignments, who should do which tasks, and also lack of communication and collaboration. You always need to talk with your team, right? Misunderstood some, for example, if some requirements are understood by two people differently, then and you are not sitting in the same place, you're not talking to each other, and if these two guys working into different components like front end and back end, it could cause some defects into your software. All right. For example, the front end understood that you need to output some result, but the front end produce incorrect result. This could cause some fixes later, right? And of course, some delay. There could also be a conflict between tasks or employees as well. Well, sometimes people just don't like each other. Okay. And also insufficient resources include budget, human, and tools, and so on. This related to other two risks that we mentioned earlier. You haven't allocated resources properly. But this one is also is interesting. Bureaucratic necessities such as paperwork, approval, meetings, all documentation, okay, takes time, take a lot of time. So if you're working in the project with the companies or organizations that require a lot of paperwork, right? For example, banks, government agencies, these kind of organizations may require you to produce a lot of paperwork when you submit your project or during your project development, and you haven't thought about that. Okay. Well, speaking from my direct experience, there is a project that we did. Okay, we ended up having to write to generate more than 500 pages of requirements elicitation process. So it took so much time. Okay, we understand that these documents are important, but 500 pages, and then you need to also fix them. Okay, the customer didn't just accept the list of requirements just like that. Okay, they have to revise and then review, and then we need to go fix them and then resubmit and so on. It took so much time and effort, and of course money, because you need to pay for your employee as well. And lastly, simply lack of experience and skills required to finish the task. Lastly, technical risks. Technical risks refer to functions or performance issues of your product. The software doesn't run properly, or it is non-functional, requirements are not met. So basically what it means is that it runs, okay? Well, it does what it does, but it doesn't do what it does well enough. Maybe it is too slow. Okay, there are a lot of downtimes. Maybe there are a lot of data loss or data corruption, performance issues, security breaches. It doesn't scale, okay, properly. It cannot handle to so much people. All right, and sometimes you have this how do we call that, dependency risks. Okay, so basically what it means is you are relying on external libraries, you are relying on external components, and one day these components got updated or got deprecated, and then your software is not compatible with these dependencies anymore. And such risks, okay, could be much higher if you're not familiar with the tools you're using. The cause of technical risks could be the lack of knowledge or experience in the application domain, right? Basically, you don't understand the domain well enough. You haven't anticipated that there are going to be a lot of connections. You haven't anticipated there are going to be a lot of users, for instance, and you have not enough experience in the technology that you use. Okay, you are employing outdated technology, and you sometimes you just really don't know. Okay, especially when you are relying on open source projects. One day, some project just die. Okay, they're just like, okay, we're not doing this anymore. We're not going to update this anymore, and now you are at risk. Or it could be that your tech stacks, okay, the choices of the tools you're using doesn't uh, work with the task at hand. So basically, they cannot deliver the task properly. And again, emergent requirements, okay, and some changes in the requirements. And again, this costs a lot of stuff. Okay, I mentioned emergent requirements many times, if you may recall. Why? Because the unknown requirements, unseen requirements can happen anytime in any project, and it could cause a lot of trouble. Okay, operational, technical, budget, risk, anything. All right. So this is why software engineering today are focusing on handling changes. And lastly, unseen or underestimated difficulties. This is just basically the task is harder than you thought. That's it for today. Thanks a lot for joining me, and please click like and subscribe. Once the new video dropped, you can just have a look at it immediately. Otherwise, you can also follow our Discord channel, and when the new video comes, I will just also inform there as well. Again, thanks a lot. Bye.